Hello and welcome to another Mr. Mario Maths video. Today we're attempting question 1 from the October 2021 Edexcel decision maths paper. And we're told we've got a Hamiltonian cycle on the graph in figure 1. And we're told it begins C, V, E, X, A, W, etc, etc. And we're asked to complete the Hamiltonian cycle. So looking at my cycle, we've got, and I'm going to use a different colour pen just to help myself out. We've got C going to V, going to E, going to X, going up to A, and then going to W. So the only option after W is to go to D because we can't return to C. So we're going to write out the cycle C, V, E, X, A, W, D. D can't go to X, so it must go to Y. And after Y, we can't go to E, so we must go to B. After B, we can't go up to V, and we can't go back to Y, so we must go to U. And then last but not least, now we've visited every vertex, we've got to return to the starting vertex, the starting node C. If you don't return to the starting node C, you won't get a mark. And as long as you stay to the letters D, Y, B, U, and C, that's going to be your first independent accuracy mark. We're now asked to use a planarity algorithm to determine whether the graph shown in figure 1 is planar, and we must make our working clear and justify our answer. So the first step is to draw our graph, but with our Hamiltonian cycle on the outside. So drawing all remaining edges inside the graph. So starting off with C, we'd start off with C down here. Let's do V, E, X, A, W, D, Y, B, and U. And I can write all these letters out. And I can join all of these edges up. As such. And the next step is to make sure we add all of the inside edges. So, to do that, we've just got to make sure we've got all the edges attached to all of the vertices. Now, fortunately, we don't have to go through all 10 vertices to check. We can make the observation that every vertex on the left-hand side is only connected to a vertex on the right-hand side multiple times, and vice versa. So as long as we checked all of the vertices on the left-hand side in figure 1, we've automatically checked all of the edges going to vertices on the right-hand side. So starting at A, I'm going to observe that A is connected to U, which I've not got on my graph, so I'm going to add that in. A is connected to V, which I've not got on my graph, so I'm going to add that in. A is connected to W, which is on my graph, and A is connected to X, which is on my graph. On to B. B is connected to U, that's on my graph. B is connected to V, which isn't on my graph, so I'm going to add that in. And finally, B is connected to Y, which I already have at the bottom. On to C. C is connected to U, which I have. C is connected to V. C is connected to W, so I need to add that in. So I've got CW. And C is connected to X, which I also need to add in. On to D. D is connected to W. D is connected to X, and I need to add that one in. And finally, D is connected to Y. And last but not least, E. And E is connected to V, which is on my graph. E is connected to X, which is on my graph. And last but not least, E is connected to Y, which I need to add to my graph. So now I can apply the planarity algorithm. I'm going to list all of the edges that are inside my graph, so not on the Hamiltonian cycle. And I could have done that previously when adding my edges to the graph. I'm going to do it really quickly now. I've got AU, AV, BV, CW, CX, DX, and EY. And to start this off, I'm going to label AU with a label I, alternatively I'm going to use I to begin with. So I'm forcing AU to stay inside my graph. However, any edge that intersects with AU must now go on the outside of my graph to make sure that they're not intersecting. So those edges are BV, which I'm going to label with an O. I'm going to get EY, which I'm going to label with an O. I'm going to get CW, which I'm going to label with an O. And I'm going to get DX, which I'm going to label with an O. So I've gone down my edge AU and I've observed each edge that crosses over it, and there's 4. I've got a bit of an issue, however. Edges BV and CW intersect with each other. If I look at BV, if I look at CW, they intersect each other. So even if I put them on the outside of my graph, like as follows, BV and CW, no matter whether I do that, they're still going to intersect. And I can't leave one of them inside the graph because they're going to intersect with AU. So I run into a bit of an issue. BV and CW intersect. Hence the graph is not planar. Full stop. So you'd have got a method mark for drawing a graph, an accuracy mark for labelling AU and BV, EY, CW and DX, or any other alternative where you started off with one edge and then labelled all the edges intersecting it. And then finally an accuracy mark for saying that 2 of the edges labelled as the same intersect, and so suggesting that the graph is non-planar. So thank you for watching the video, and until next time, goodbye.